Så, hallå, välkomna till Ramens webbinar på ämnet vätgas. Kul att så många är här. Hoppas ni har haft en bra morgon och att vi kan köra igång för klockan är 9. Alla är beredda. Vi får se om några till ansluter. Dagens agenda är som följer. Jag kommer att välkomna er och göra en liten introduktion. Vi kommer ha en introduktion av HEROSE. Och sen så ska Jürgen Louis från HEROSE prata lite grann om då olika typer av ventiler för vätgas. Och vi pratar lite olika typer av applikationer och så ska vi försöka hinna med lite frågor på slutet. Vi har 30 minuter på oss. Så det blir kondenserat och bra det här. Men en bra start på dagen. Börja presentera mig själv. Per Wennersten heter jag. VD på Ramen. Jobbat på Ramen nu i snart 13 år. Med försäljning bland annat. Med mig har jag då Jürgen Louis som är produktchef för vätgas på HEROSE. Som kommer att prata alldeles strax. Jag börjar bara nämna lite vad Ramen, vilka vi är. Vi är ett företag som har funnits sedan början av 1900-talet. Vi håller till i Bromma för Stockholm. Vi har våran tillverkning då i Fagersta i Västmanland. Vi är 12 anställda. Vi distribuerar då våra ventiler runt om i världen. Vi omsätter ungefär 50 miljoner svenska kronor. Vi håller på med då reglerventiler, processventiler, säkerhetsventiler, tanksäkerhetsventiler, olika typer av automation, men vi gör även väldigt mycket som har att göra med då tjänster som att beräkna och välja och ventiler i olika applikationer inom processindustrin, men även service och underhåll av processutrustning. Det vi sysslar med på Ramen är vi tillverkar våra ventiler som vi distribuerar i hela världen, men vi är ju även stolta representanter för våra agenturprodukter där vi har då Casco, Badger, Controlair och med flera som vi då distribuerar i Sverige och Skandinavien. Men det vi ska prata om idag och den största är ju HEROSE, tyskt företag som har funnits sedan 1800-talet. Håller på då mycket med kryogena applikationer. Jag kommer att gå över till engelska nu. I will say hello to my colleague Jürgen Louis and I will hand the presentation over to you and let you introduce yourself, Jürgen.
Yes, I will share my screen so we can see what I'm talking about. This one sec. Can you see the presentation?
Yes.
Yes, thank you. So my name is Jürgen Louis, like Per already said. I've been with HEROSE for about 2.5 years now, working as business development manager for hydrogen. And before that, I've worked on hydrogen for maybe 15 to 20 years. Amongst others, as technology manager for hydrogen in Shell. So a long background. And the presentation today will be a very brief introduction to HEROSE, 3 slides only. Some slides on our valves for hydrogen with a limited technical explanations and a large part on reference projects. So where are we using the valves and where have we sold them? So HEROSE is a company which is 150 years old. Last year we had our celebration, 150 years. And it's a family-owned company, worldwide active. We produce about a bit more than 500,000 valves per year. So quite a substantial amount. And our turnover is 95 million, bit more, with 500 employees, mostly in Germany. So all our valves are made in Germany. At least all our hydrogen valves are made in Germany. Some other locations are in Australia and in India. So our background, so mainly we sell valves for the gas industry. So on the left side, we can see the LNG value chain. So if you look at cruise ships, about 75% or more than 75% of all cruise ships that are fueled by LNG use HEROSE valves. Last I counted, it was 17 large cruise ships. We do LNG filling station, everything, lots of things on LNG. The second part is industrial gases, so air separation plants, oxygen, nitrogen. So the industrial gas companies, there are our main companies, customers. And on the right side, you can see the new branch, which is hydrogen, and we go for liquid hydrogen, so cryogenic hydrogen, and also for high pressure hydrogen. And we deliver to hydrogen fueling stations. We deliver valves for trains. We liquefaction plants. We will see that later. So these are our main three pillars. Of course, there's also the valves are used for many other applications as well, but these are the main three. And one of our main focal points, and it's also, of course, important for hydrogen, is quality. So we ensure that our valves that go out have the highest quality. And that starts with the development of the valves. So a lot of testing, a lot of know-how that goes into the valves, to the purchase of materials, raw materials, only good materials, suppliers we have long relationships with, to our production facilities, so modern machines, everything made in Germany, good people, and of course then very important for our customers is all the certifications that we have. Of course the ISO certifications, but all the approvals from, for example, shipping classes. You can see here on the bottom of this slide. So quality is one of our main focus, which is for hydrogen, of course, very important. Going into the valves, this is the overview of the value chain for hydrogen, and actually we are present almost everywhere. So if you look at production on the left side, we sell valves for electrolyzers, we sell valves for chemical plants, so steam methane reformers, gas separation units. Then going to storage and transport, so you can transport pure hydrogen in two ways, either as pressurized gas, usually around 250, but also 500 bar, or as liquefied hydrogen, cryogenic temperatures at minus 255 degrees Celsius, which is low, even below the temperature of liquid nitrogen. So there's some special requirements to the valves to be able to do that. And then we go into end use. So as I said already, we sell a lot of valves, a lot of safety valves, especially for gaseous hydrogen filling stations. We sell into mobility with trains and also trucks. We sell a lot of liquid hydrogen valves for rocket launch platforms, for example, not in the rocket itself, but to refuel the rockets. So all these applications we sell hydrogen into. And separately mentioned here on the bottom left is the ammonia pathway. So our valves also suitable for ammonia. It needs some special changes. We call it the S version of our valves, and then they are suitable for ammonia as well. So ammonia is often transported as a cryogenic liquid, but only at minus 33 degrees Celsius, and our valves are used for that. An overview of the valves from left to right. The top entry valves, these are valves you can access from the top, so you can build them into a system, and without taking the system apart, you can access the valve, do maintenance, exchange parts. That's especially important for hydrogen, if you have cryogenic hydrogen and you don't want to get any heat into the hydrogen. You can vacuum insulate the valve, so put tubing on it, make it vacuum, and so you reduce the heat leak into your hydrogen at that point. But that means you would have to break the vacuum if you want to do maintenance on the valve. But these valves you can enter it from the top, so the vacuum remains intact, and you can do the maintenance without taking the valve out of your system. So this is used for liquefaction plants, hydrogen liquefaction plants, but also for the distribution systems, so for tanks, for trailers. So basically everywhere where you don't have easy access to the valve for maintenance. So then the 4 pictures next to that with our, I would not say standard, but our more normal globe valves for hydrogen. So you cannot access these from the top. So you would not use them for a vacuum insulated system. But if you want to transport hydrogen either as cryogenic fluid or as gas, you can use these valves. So they're just all optimized for hydrogen. It's our special valve range with better materials and go to a lower temperature. The nice things about these is that they are not incredibly expensive. Often you hear hydrogen valves are expensive because it's hydrogen. These are based on our standard valves, and they are not hugely expensive. So it would be a fit-for-purpose solution for an affordable price. And we have sold a lot of these. We'll go into that later for piping systems, for liquefaction plants, for export terminals, for example, in Australia. We also sell these a lot for ammonia. And the valve types we have here, normal straight-through globe valves, actuated valves, and all kinds. We have check valves and we have strainers, and the sizes go up to the DN200, these valves. On the right of that, I've highlighted the safety valves. We have basically 2 ranges. One range is safety valves up to 50 bar, which is suitable, very suitable for electrolyzers, for example, if you have pressurized electrolyzers, and our high pressure safety valves, which are used more after compression, so in pipelines, in tubing for hydrogen stations. All these valves are cryogenic and go up to also to high pressure, high temperature. So we all go from at least minus 255 to plus 120. Some go higher, some go to 400 Kelvin, some goes down to liquid helium temperature, so minus 270 degrees. So the full range there. And the highest pressure we currently do is 550 bar. I will have a slide later on where I show the efforts we're doing to get up to 1,200 bar, and that would then be able to refuel vehicles at 700 bar stations. Completely to the right, it's a new valve type we have just introduced, and this is special for, well, we sell them mostly for trains. So it's a big customer that makes hydrogen trains, and they have high pressure hydrogen on the train at 350 bar, and the fuel cell does about 4 bar. And to protect the fuel cell, so if something goes wrong, the fuel cell should not be damaged. We put a safety valve or a changeover valve, both if possible, or changeover valve, a overflow valve, both if possible, on the system to protect the fuel cell. So it will blow off the hydrogen to the vent at 4 bar. And the special thing about this valve range is that it doesn't have an inlet and outlet in 2 different directions, but they all both go downwards. So you can have a block with holes drilled into it, screw this safety valve in, and you don't have to put in any additional piping because the inlet and the outlet both go into the block. So this is a bit of a special case. We have to work with the customers to get all the connections right and the sealing tight. So these are on request, but it's a valve type we are promoting right now. So the only technical slide I have, because if you talk about hydrogen, you have to talk about hydrogen embrittlement. So this is the effect that hydrogen reduces the ductility of some of the metals we use. And because we are using cast bodies, you can see a picture on the right of a cast bodies, for a lot of our valves, we had to do some extra work here because there's no information whatsoever in literature what the effect is of hydrogen on cast steel. So we did tests at an institute with hydrogen. So we filled the metal with hydrogen by having it under 100 bar or 50 bar hydrogen at 240 degrees for 11 days. So the material was completely filled up with hydrogen. Everything that can diffuse into it was in it. And then at the worst possible conditions, we did the embrittlement test. This is minus 50 degrees. And the cast material worked fine. But we decided to increase the nickel content of our material by a bit to make even better resistance to hydrogen. So all our metals are special. They're still the standard steel, but the bandwidth of the composition is very narrow, so that we are very good for hydrogen with this material. I will skip the welding part. Is very specific for some people. If you have any questions about welding with hydrogen, please send me a note and we can have a discussion in detail on that, but I think it goes a bit too far to go into there now. So we control our bodies, our materials, especially to see if they are suitable for hydrogen. So if the chemical composition is okay, we measure the ferrite. So it's basically the structure of the hydrogen of our bodies before we use them for hydrogen valves. And we made this as a standard for all our hydrogen cast valves, so you can get automatically the better quality materials. Just shows that hydrogen is not different from other materials, but you have to take into account some special things about hydrogen for your valves. Then very briefly from our development department. So what are we working on? What can you expect by the end of this year, maybe early next year? So one project is a new valve. On the left, it's a stop valve. So intended to be used on hydrogen trailers. So transporting hydrogen from one place to another under pressure, and the pressure of the hydrogen trailers are going up. So will it be above 500 bar soon, because you get more hydrogen on your trailer at these pressures. This valve is intended to be the valve between the bundles of storage bottles, between each others and between the trailer to the customer. So it's actually it's an end valve, so it has to be very, very leak tight, because if any leakage which goes through the seat will end up external, and it has to have very high durability, because these valves are opened and closed a lot, so you need a large number of cycles. So we try to make a valve which is very suitable to this, and we have several prototypes already. You can see one picture of one of the prototypes, which is currently being tested, and will also be tested at an institute with hydrogen, so we can be sure that it will work correctly. In the middle is the one I already mentioned, the 1200 bar safety valve for hydrogen stations. You can see a prototype there on our new test facility. So as I said, we went up to 550 bar up till now. We have to have new equipment if we want to go to 1200 bar. So that's all in-house, and we can do our own tests. This valve is for refueling of trucks and cars at 700 bar. And it's basically based on the existing valve of 550 bar. It has a narrower opening to make it suitable for the higher pressure. And the test here, you can see it's being done at 963 bar, which is the most normal pressure for a hydrogen dispenser at a filling station. So these are both gas valves. Looking at the high pressure side, of course, the cryogenic side, we are also doing a lot of work, and we are working hard on our top entry series there to make it wider, to have more variations. So the picture shows here something we have just introduced a few so weeks ago, which is a check valve for cryogenic systems with top entry, so the maintenance can be done from the top. At the moment, we have it in size 25. But the whole Fulex product range, top entry product range, is that we want to extend it to more products and larger sizes. So it's our typical hydrogen valve. Then on projects, going back on the Fulex range, where have we used it? Where can we use it for? So as said, it's ideal for vacuum installation because you can maintain it without breaking the vacuum. We sell it for liquid tanks, trailers, for cold boxes for hydrogen liquefiers. We have requests, although not sales yet, for liquid hydrogen fueled ships. We sell that for rocket parts. We go up to DN50 at the moment. We are extending it to DN100. At the moment, we have a different range top entry for DN100, which will be replaced over time with Fulex. We've done tests with this. So one of our biggest customers is Chart, and they have tested it in the US and also approved it for their systems over the whole Chart group. And they said we have not detected any leak during any of the tests we have done with the valves. The specifications are actually better than we put in our leaflet, and actually it's the easiest valve to operate that they have tested, so they were very positive about it. Sales, we have sold it for a hydrogen vaporizer, for example. I might have a different slide on that, so I will not go into detail on that. And also for helium applications, so we go down to liquid helium with these valves. As PAD and TPAD approval shipping class, we are also doing tests with liquid hydrogen to get shipping class approvals. These are now ongoing. And the picture you can see the valve at Chart actually installed for doing the testing. There's an actuator on top of it here, so you can remotely activate it. And the right picture is an internal test with liquid nitrogen, where you can see we have installed it upside down, and the cold from the liquid nitrogen does not come to the handle. So there's a lot of testing going on this valve. The high pressure safety valve, you can see the way it looks and the range limit. So where have we sold it? So we sell it for cryogenic and warm applications, so for cryogenic and high pressure applications. We have sold it for hydrogen filling stations, electrolyzer, compressed storage, and a number of the customers you can see here. So it's a very common valve. We sell it a lot. And for cryogenic applications as well, for liquid hydrogen traders, we sell a lot of these. It has a lot of certifications as well. Then I have 3 projects I think I want to briefly discuss. So one project is a hydrogen liquefier in the US, 60 tons per day, so big plant. I think it's the biggest one being built right now. To this plant, we supply our mid-range valve portfolio. So the types numbers you can see here. We do not supply the valves for the cold box there because it's made somewhere else. But this is for the piping system from the liquefaction plant to the distribution to the trailers. So to the pumps, the pipes, the intermediate storage, and these kind of things. When the boil off comes from the trailers, it goes back to the plant. These valves handle that. So it's in the middle of the distribution system. And we sold about 300 valves for this plant, so quite a big plant. Similarly, the other way around, so regasification. So you have liquid hydrogen. This is actually a project in France. They have a liquefier in France. They truck the liquid hydrogen to a customer. The customer wants gaseous hydrogen through a pipeline, so they regasify the hydrogen at the plant. So the gas company regasifies the hydrogen where they need it and then put it in a local pipeline to the customer. And it is actually a quite nice project because we sold all the valves in this plant. So the hydrogen valves, we sold the nitrogen valves, we sold full access there, also safety valves. So this is, in the end, we had just for the regasification, we had about 200 valves for 2 trains of regasification in this plant. And finally, I also showed ammonia on one of my first slides. I just wanted to highlight for me ammonia as a part of hydrogen because ammonia is used to transport hydrogen, store and transport hydrogen. And this is a very big, or these are actually 2 very big projects from an American gas company. One project is in Saudi Arabia, one is in the US, where they have a ammonia plant. So they have renewable or either renewable electrolysis or a steam methane reformer with carbon capture. From the hydrogen, they produce ammonia, so NH3. For that, you need the nitrogen as well. So you have an air separation unit next to the plant. And this company basically buys all the valves, or I don't know all, but a lot of valves, because 1,200 valves for these 2 plants here. And these are for the ammonia. They use the S version, and some of our valves have a copper part in for the reducing the wear in the valve. And for ammonia, we replace that with a steel part. So it's the S version of our valves. So this is a really huge project for us, and has been going on for 3 years right now. So green ammonia. And that's all I had for today, which I could do in 20 minutes. These are my contact data. So if you have any questions, feel free, send me an email or to call me. I'm happy to talk much longer about hydrogen.
Yeah, thank you very much, Jürgen. It was very interesting and very informative, very condensed presentation. I seen you giving the long presentation. This was the short version. So, but I hope everyone got a good insight in the wonderful world of hydrogen. Thank you very much, Jürgen. I will switch to Swedish. Tack till Jürgen, och har vi några frågor så här innan vi rundar av? Jag har inte fått in några frågor på chatten utan vi får väl i så fall om det finns frågor så går det jättebra att Jürgen finns på plats. Jag ska även avsluta här nu med att då gå tillbaks och titta på frågor, och det här är mina kontaktuppgifter. Om det är någon som har några frågor så går det bra att kontakta mig också. Annars så tar vi och rundar av för idag. Så gör vi. Thank you very much, Jürgen, and tack till alla som har varit med. Och ha en jättebra dag. Så hörs vi säkert snart igen.